So at the top of 9.6, we're going to find all the trig ratios from angle K. And then we're going to leave the answer in reduced fraction form. So before I even find the trig ratios, what do I need to find first? My missing side. So I know two sides, and I need to find the third. What do I use? Pythagorean Theorem. A squared plus b squared equals c squared. Which of these is c? 34. And we'll have 16 squared and x squared. 16 squared is 256 plus x squared. What is 34 squared? 56. Okay. 1156. Subtract the 256, which means x squared equals, bless you, 900. Take the square root. That means that missing side is 30. All right, so we're going to find sine from K, cosine from K, and tangent from angle K. So to do sine, we got to do so. So what is the opposite of K?
16.
And then hypotenuse, 34. It says reduced form, so I'm just going to write it over here. What is 16 over 34 reduced? 8 over 17. All right, and then we'll do cosine, which is adjacent over hypotenuse. What is adjacent? 30 over the hypotenuse. 34 still. What does that reduce to? 15 over 17. Last is tangent, which you can remember TOA. So that would be 16 over 30. What does that reduce to? 8 over 15. So let's talk about why we have done this. You did this to learn sine, cosine, and tangent, and in the previous section we found side lengths using this. But what is missing in each of these equations? What do we not know the value of in each of them? K. So technically any one of these would help us find K, and our goal today is to teach you how to type it in your calculator to find that. Okay? So it's literally 2 buttons. I'll show you. And then you would have angle K using any one of these. All right, and even more review. Solve for the missing side lengths. We're going to round to the nearest tenth. So which side length do you want to find first? The opposite, which is PR. So our goal is to find PR and to find RQ. So keep that in mind when we go to solve this, that we want to label them PR and RQ. But we want to find PR first, that's fine. You can call it X, but just remember that we made up X, and in the end, we still have to call it PR. But what kind of side is PR? Opposite. And what kind of side is 22? Hypotenuse. So which trig ratio are we going to use? Sine. From what angle? 37 degrees equals the opposite, X over the hypotenuse, 22. Do I need to flip this? No. Multiply times 22. We are rounding to the nearest tenth. So what do we get? 13.2. All right, so remember we made up the letter X. So we say PR, the length of PR is 13.2. We still want to find the length of RQ. I would not call it the same letter, just so you don't get confused. I'm going to call it Y. You can call it whatever you want. But what kind of side is RQ? Adjacent. And then you still want to use the hypotenuse because you know that it's 22. It's not rounded. You know, we didn't find it. So which trig ratio are we going to use to find RQ? Cosine. Bless you. From 37 equals the adjacent, which we called Y, over the hypotenuse, 22. Do I need to flip this one? No. Multiply times 22. What do we get rounded to the nearest tenth? Okay. So remember, our Q is 17.6. We made up the letter Y. So here's what we're doing today. This section is called solving right triangles. All it means is finding all the missing sides and all the missing angles. You already found the missing sides in this problem. The only extra step that we would do in this section is find angle P. So we already know how to do that, though, don't we? What do the three angles in a triangle add up to? 180. You know you have 90 and 37. You can add them and subtract from 180. Option 2, what does P plus Q, what do they add up to? 90. So you could always do 90 minus 37 as another option. But either way, what is the measure of angle P? It's 53. That's the only extra thing you're doing in this section, other than we're going to find angles using sides in a second. But if this question said solve the right triangle, that's the only extra thing. Questions on this? The last thing, this is from your last test. Determine which of the two acute angles has a sine of 0.4. So which of these angles are acute? R and Q. So I had a lot of people say angle P. Is that an acute angle? No. You'll never find sine, cosine, or tangent from a right angle. It's just not going to happen. So what you want to do is find sine of each of them and see which one equals 0.4. Sine from R would be opposite over hypotenuse. What is the opposite? Over the hypotenuse. Does that make 0.4? It does. So our answer is angle R. Angle Q would have been, sine of that would have been 3 square root of 21 over 15, which does not equal 0.4. So angle R is our answer. Which brings us to today's lesson. It is called solving right triangles. So on page 2, you're going to fill this in. To solve a right triangle means you find all the missing sides and all the missing angles. So on page 2, we find all the missing sides and all of the missing angles. Find all the missing sides and all of the missing angles. And you're able to do that with either one of these situations. They're both on your paper. Given a side and an angle, and then also given two sides. So we already know how to do this one. We just did it, with different numbers. To find our angle, you subtract from you either add these, subtract from 180, or just subtract 50.1 from 90. Either way, you know how to find angle B. And then how would you find the side lengths if you have a side and an angle? It's either the Pythagorean Theorem or trig ratios. We'd use trig ratios, all right? So this one's not new. We know how to do it. We got tested over it. Y'all rocked that test. Given two sides, however, this is what's really new to us. We would want to find the length of CB. So we'd want to find CB. It's a side, right? And you know two sides. How do you find the third side if you know two sides? Pythagorean Theorem. So a squared plus b squared equals c squared would help you find the length of CB. But will the Pythagorean Theorem ever help you find an angle? It will not. So to find the angles, we will use trig ratios, which are sine, cosine, or tangent. So this is what's new today. We'll learn how to do both technically. But yeah. So first we're going to teach you how to type things into your calculator because it's special. All of your calculators are capable of doing it. There's not one calculator that's easier than the other. But in any equation, you have to use the inverse to undo something, right? If I had x plus 4 equals 2, all right, and I wanted to get x by itself, I have this plus 4. What is the opposite of plus 4? Minus 4. The same thing with If I have multiplication, what's the opposite of multiplication? Division. So you always have to do the opposite action to get x by itself. So what you're going to see is a problem like, I'm just going to make one up. Sine, what was it? Sine of k, I don't remember what it said on the first page, was like 8 over 17 or something like that. All right? Do we all know that fractions are the same as decimals? So this could be a fraction. They could have written a decimal. It doesn't matter. It's the same thing. But essentially, what's missing is angle k, right? We need to get k by itself. What is k attached to? Sine. So you have to use the inverse of sine to get rid of sine. The inverse of sine is called arc sine. It looks like this. But if I did it to the left side to get rid of sine, I would have to do it to the right side as well. So I'll teach you the button to make sine to the negative 1 pop up if you haven't found it. You would hit shift, sine. So in your calculators, type shift, sine. Shift is in the top left. And then sine. And then you would type in 8 divided by 17. You don't have to make it into a fraction. You just do 8 divided by 17. And then normally it asks either to the 10th or to the whole number. Yep. You don't have to close it. You can. Well, this is easy. Okay, let's do the whole number since it's pretty easy to round to. What does that make? 28. So angle K is 28 degrees in that situation. So what you're going to learn today is if you have tangent of angle A, to get rid of it, you have to use the inverse of tangent. If you have sine of angle A, to get rid of it, you have to use the inverse of sine. Same thing with cosine. They're technically called arc sine and arc cosine. If you ever use the graphing calculator on Big Ideas or maybe even Google, they're called arc. Did everyone find it? Okay. All right. This is just saying we can read it as the inverse. Technically, it's called arc tangent, arc sine, and arc cosine. But anyways, let angle A, B, and C be acute angles. It doesn't work if they're not. Use a calculator to approximate the measures to the nearest tenth of the degree. So in the first one, we have tangent of angle A is 0.75. So to get rid of tangent, we have to use the inverse of tangent. So you're going to hit shift tangent. Shift tangent of 0.75. We are rounding to the 10th like it says. So what do we get? 36.9. Second one, we have sine of angle B equals 0.87. So again, to get rid of sine, we have to use the inverse of sine, which is technically called arc sine. Whoop. So shift sine of 0.87. What do we get to the nearest tenth? What is it? 60.5. And then we have cosine of C equals 0.15. So shift cosine of 0.15. And what do we get? 81.4. Good. Is everyone okay with finding angles using the inverse? Okay. So, you need to know the difference between these two. You're going to see them on your quiz or your test, and it's going to ask you to find something. In this first one, you had this on your last quiz at least, where it says sine of 33 degrees. Is the angle missing? No. It says sine of 33 degrees. There's nothing really like new about this. You would just type in sine of 33 degrees, and you would get your answer. So here's what the difference is. This one, you're given an angle. The angle is 33 degrees. What you would find when you typed it in is the trig ratio. So go ahead and write that down. You're given the angle, that's 33 degrees. And what we would find is the trig ratio. So you're given the angle, and you would find the trig ratio. Then when someone's ready, can you type in sine of 33? We'll round to the thousandth, which is 3 places. 0.54. So 5. So the trig ratio is 0.545, and the angle is the 33 degrees. So in what we're learning today, the angle is x, and the trig ratio is 0.333. So we're given the trig ratio, and you're missing the angle. I'll tell you why I'm showing you this. But you're given the trig ratio, and you would find the angle in this particular problem. And I'll have you write down and highlight something. Missing angles. I'm trying to abbreviate just to save you some time. But for missing angles, you will use the inverse. And that's the shift, plus whatever the trig ratio is. So whenever you're finding an angle, you will always use the inverse. If you know the angle, you will not use the inverse. But if you're finding an angle, you have to use the inverse, or you're going to get a decimal. That will not make sense. So in this case, you're finding x, which is an angle. You would use shift sine on both sides to cancel out sine. What is shift sine, so inverse of sine, of 0.333? 19.5 degrees. If you got a number that's like 1 or less than 1, it is not going to be ever the answer. You will really never find like 1 degree angles here. All right, so we're going to use this information. Here, find the measure of angle A, round to the nearest tenth. Nope, no, I lied. Round to the nearest degree. So we want to find angle A. All we want is angle A. Can I use the Pythagorean theorem to find an angle? No. Have to use a trig ratio. So to figure out which trig ratio, we have to label the sides like normal. So you're going to label 12 and 13. What kind of side is 12? Adjacent. And what kind of side is 13? So which trig ratio will we use? Cosine from angle A will equal the adjacent, which is over the hypotenuse, 13. So we're solving for an angle. You will use the shift button. So the measure of angle A, you'll do shift cosine of 12 over 13. You do not have to make it a decimal. You could just type in 12 divided by 13. Same thing. We're rounding to the nearest degree, so a whole number. So what do we get? 23 degrees. Doing the same thing for number 2. We want to find angle A. So what kind of side is 4? And then 13. So which trig ratio will we use? Tangent from angle A equals the opposite over the adjacent. Going to use the inverse of tangent to find the measure of angle A. So shift tangent of 4 over 13. What did we get? 17 degrees? 70 degrees. 70.
17.
Used cosine. 17 degrees. All right, so now we're going to level up. All right, this is as hard as they get. Solve the right triangle. Before we start, we're just going to make like a goal here. To solve a right triangle means find all the missing sides and all the missing angles. So we want to find the length of AB. We want to find the measure of angle A. We also want to find the measure of angle B. That's our goal. Doesn't matter what order you solve them in. It really, really doesn't. you can start wherever you want. I usually start with the length there, because how do we find the third side if I know two sides? The Pythagorean Theorem. So that's where I would start. A squared plus b squared equals c squared. And we're going to find c. C is the hypotenuse, so I'm just going to keep calling it c. So a and b would be 3 squared and 2 squared. What is 3 squared plus 2 squared? 13. So 13 equals c squared. Take the square root. We are rounding to the nearest tenth, which is 1 decimal place. So what do we get? 3.6? Okay. So again, I would just go back over here and write it in 3.6. To find our angles, what is the only way to find angles if you are given side lengths? Trig ratio. So we have to decide which trig ratios to use. I'm going to start with A because that's the one I listed. So from angle A, you want to use the two sides you were given. You don't want to use the one you found because it was rounded. It could be wrong, all that stuff. So what kind of side is 3? And then 2? So which trig ratio will we use? Tangent. Oop. Tangent from angle A equals the opposite, which is 3 over the adjacent 2. You're going to hit shift tangent of 3 over 2. What do we get? 56.3. So again, I'm going to come back over here and write it down. 56.3 degrees. I'm not going to look inside of your triangle to find your answers. So please make sure they're outside of it, boxed in or something, because these usually could have a lot of work. Now to find angle B, you could technically do the math, subtracting from 180. My only hesitation is that if you were wrong there, you would be wrong again. So it takes an extra 1 minute or less to find angle B using a trig ratio. So I would use the 180, like that they added to 180. I would use that as a way to check, not necessarily a way to find that last one. Because from angle B, what kind of side is 2? And what kind of side is 3? So which trig ratio would we use? Tangent from B equals the opposite over the adjacent. And then you hit shift tangent of 2 over 3. What do we get? 33.6 degrees. So like I said, I would just use these two should add up to what number? These two angles?
It's 33.7.
Oh, I'm sorry. Nonetheless, these two should add up to what number? They should add up to 90 because 90 plus the right angle make 180. Okay, so use that to check yourself. So this is like as hard as they get when it comes to like the new questions. We're going to do one more together. You already know how to do this one. Solve the right triangle. Round your answers to the nearest tenth. So solve the right triangle means you're going to find everything. We're going to find the measure of angle T. We're going to find the length of RT. And we will find the length of ST. That's our goal. Which one is the easiest one to find? That could be easy. I would say angle T is the easiest to find first, because you already have 24 and 90. You can add them, subtract from 180, or S and T have to add up to 90. So 90 minus 24 is 66. So you're already 1/3 of the way done with the problem. We can find RT first. We can call it X. But remember, when you go back to list your answers, there's no X in this problem. You have to say RT equals. So we're going to do from 24. What kind of side is X? Opposite. What kind of side is 33? Adjacent. So which trig ratio will we use? Tangent. From what angle? 24. So if you know the angle, you have to write the angle. If you don't know the angle, that's when you write the letter. So tangent from 24 equals the opposite X over the adjacent 33. And especially so, would we want 2 letters missing in this equation? No. Especially not if we know it. So we have tangent of 24 equals x over 33. Do I need to flip this? No. Multiply times 33. We're going to round to the nearest tenth. 14.7. So again, don't circle x. You made up the letter x. It doesn't actually exist in this problem. The length of RT will be 14.7. I would not use the Pythagorean Theorem just like before. We wouldn't use it because we rounded, then we would square the rounded, and then we would add the rounded, and then we'd square. We do a lot with it. So I would use the trig ratio again to find the hypotenuse, all right, which is what's missing. So we want to find the hypotenuse. I would still use a trig ratio using a side you do know, or like the one you're given, and a side you don't know. So which trig ratio would we use here? Cosine. From 24 equals the adjacent, 33, over the hypotenuse. You can call it whatever letter you want. I'm going to call it h, because why not? Do I need to flip this one? I do. So I flip both, and then I multiply times 33. So what is that hypotenuse going to equal? 36.1, we agree?